afternoon, everyone. This is Kevin Gianni from the Renegade Health Show, and today is Tuesday, and today we have a very special interview. We've had some great interviews. We're going to have some more coming up. Today we're going to be talking about a game-changing planting technology. So if you're a gardener, or if you want to garden, or if you've been gardening, well, I guess that would mean you're a gardener, or a sprouter, or growing wheatgrass, you want to check this out. Tell us about Ocean Solutions specifically. So there's people who have no idea what it is, what to do with it, or anything. So let's start on the very basic.
Okay. It's all 90 natural periodic charred elements.
There it is.
In the universe.
Mm-hmm.
Well, no, that's not completely true, because what it is that those are the 90 that occur naturally on Earth. You know, you'll notice, well, on the shirt, yeah, you'll notice the two yellow ones.
Mm-hmm.
Technetium and promethium.
Okay.
In chemistry class, they teach you that the first 92 are natural. The only trouble is these aren't natural here. They don't occur here. They're in stars and there are other places,
I see.
but
Okay.
they've never been here. We've hypothesized they might have been here in the early days, depending on your worldview. But they don't occur. They can make them in a particle accelerator and those kinds of things, but they don't occur here. But the interesting thing is that everything in the universe is made up of elements. These are the building blocks of everything: stars, trees, cars,
Mm-hmm.
blackboards, chalk, maps, faces, eyeballs, everything. Everything's made up of elements.
Right.
And we've never seen any foods, now we're into foods, that have an edible food, that a human edible food that had less than 40 elements. And actually we're sort of revising that as our testing gets better, that probably at the end of the day we'll find that probably no edible foods have less than 50, maybe even higher than that.
Okay.
The recent corn study, we revised our views about that. The corn study came back at 72 elements.
Okay.
And so every different food has a genetic requirement to pick up a number of elements, and proportionality. In other words, it'll be different proportions within the element, like it'll need so much of this, so much of that. And so in our conventional agricultural practices are that we use 3 elements: nitrogen, potassium, and phosphorus, sometimes sulfur, sometimes boron, sometimes a few other things. Calcium is another one. So we sort of have 3 plus 3, plus some advanced farmers will use trace element packages or something. But it's the proportionality of what they use is not based on anything. It's just, let's try some of this and try some of that. But actually, the plant wants to see very specific proportionality of elements. And what's interesting about the seawater proportionality and our product proportionality is that it actually has a relationship to something.
Mm-hmm.
And that something is, if you look at chlorophyll, it's very nearly the same as seawater, except it's magnesium-based, seawater sodium-based.
Mm-hmm.
If you look at human blood, it's quarter-strength seawater exactly, except it's iron-based. The major element is iron, but then all the other elements are in the same proportion in the same water as seawater. So, at least our method has sort of a basis in reality, whereas, NPK agriculture, by the way, I don't want to start a fight with the NPK guys.
Right.
Everybody's trying to do the best they can. They just happen to have started on a flawed model.
Right.
And an expedient model, and not on a model that would grow good food.
Right.
In fact, if you look at the things that were commercially available to use as fertilizers, there weren't a lot. And the federal government only recognizes 16 elements as essential for growing food.
Hmm.
But why did they pick 16? Because the 17th is impossible to commercialize. The 18th, forget it. The 19th, you know what I'm saying? In other words, 16 you can actually mine and
I see.
And commercialize.
Okay, gotcha.
So it's not because there was good science and said, yeah, we only need 16. No, you need 90. All the grasses need 90: alfalfa, rye, oat, wheat.
Mm-hmm.
They need 90 elements to be correct. And we talked about this on the call, but if you look around at nature and you look at things that have one food source, a grazing animal, goats or sheep or wildebeest or whatever, they have one food source, and it's grass.
Yeah.
How do they be, they're strong, they're healthy, they don't get osteoporosis. One thing, what's special about that one thing? 90 elements. It has all 90. And anyways, so our product, we can't call it a fertilizer because fertilizer definition is skinny. It's very thin, what a fertilizer really is. And the legal technical definition of fertilizer is nitrogen, potassium, and phosphorus, and the percent that's available, that's soluble. And when you get a fertilizer bag from the hardware store, it'll have 3 numbers.
Yeah.
And those numbers are nitrogen percent, phosphorus percent, and potassium percent. And we label that on our label, not this label. I'll show you another label later. But now we've revised our labeling, and it conforms to all the regulations in most of the states, and we list it, but it's a very small number. So anyways, our product, is a plant nutrient mineralizer, remineralizer. It's a true food for a plant. And the benefits of using, obviously, it wouldn't be commercially viable unless it would, most growers, and rightly so, are, the prime metric is yield. Does it yield well?
Right.
Because you're not going to sell a underperforming product, even though it's green. Green is not good enough to sell somebody if it doesn't perform. So we have to outperform the chemical conventional growers. But the benefits are that if you grow a plant with all the elements that it requires, you get interesting side benefits, which are healthier, more vigorous plant, able to withstand stressors like high and low temperature, high and low water, too much water, too little water, and diseases of all, funguses, bacterial things. In a typical application, every crop is different.
Right.
And then within every crop, there are differences. There are geographical differences. But an average type program would be, for commodity crops, which have very low budget for inputs, fertilizer inputs. Our application rates could be a little bit under a gallon per acre per year.
Okay.
The range, so there's commodity crops, sort of under a gallon, sometimes up to 2 gallons per acre per year, all the way up to the high value applications like, table crops, row crops, sweet corn, but more like tomatoes, cucumbers, melons,
Right.
squash, green peppers. Those are high value. They're worth a lot, so the growers use a lot of money. They invest a lot of money to grow them. So in those applications, it could be 10, 12 gallons a year per acre per crop.
Okay.
But they're used to that budget, and we can compete at those rates with NPK.
Yeah. What would be like a cost comparison from
Okay.
NPK to?
Well, green peppers, sort of in Florida anyway, the average input cost for fertility, not protective chemicals, not fungicides and pesticides.
Right.
But in Florida, they probably, for green peppers, it's right around $900 per acre per year in fertilizers. So we come in and we say, okay, we're going to use that $900 our way and outperform what you're doing without even taking into account the savings from not using as much fungicide or any fungicide and a large reduction in the insecticide.
Hope you enjoyed that interview. Your question of the day is this: are you a gardener? Go ahead and post it down below, yes or no. Anne-Marie and I are turning into gardeners this week. We're going to clip off our black thumbs, we're going to turn them into green thumbs, and we're going to show you. This is Kevin Gianni. Please pass this episode. Please pass this episode along. Together we can change the health of the world, one show at a time.